Fractions. Huh? No. Fractions. All right. Fractions. Now, fractions just basically means parts. Like when you're fracturing something, you fracture your arm, you're breaking your arm into two parts, unless it's multiple fractions. Fractures. All right. Now, basic math, 3/7. Just for you guys that are uninitiated, that top number we call the numerator. Like to numerate's like the count. This is what you count with. There are 3/7, basically. That is the denominator. So when we're talking about denominations, it's all based on this. When we're talking about 3/7, what you're saying is there are 3 of these guys. So if I said this, there are 3 quarters. You know what that means, yes? There are 3 of something. What are those somethings called?
Quarters.
Quarters. Same thing here. There are 3/7. There are just 3 of these things here. Here is 1 whole block. I'm going to cut this block into 2 equal parts. So this is 1 whole block, correct? But I cut it into how many equal parts?
2.
And how many parts are there?
2.
All right. Or you can think of it as 2 halves. I could split it again. Let's say these were equal in size. So how many pieces did I cut it into? 4. And what are they called? 4 quarters. This is my denomination, or my denominator, you can say. 2 halves, 4 quarters. So the halves is my denomination, or my denominator. Quarters is my denomination, or denominator. Now when I'm talking about quarters, they're just saying, instead of writing the word quarters, how many quarters make up a whole? 4. So instead of writing it this way, you can write it as 4 quarters right there. Instead of writing 2 halves, how would you write half as a fraction? So it's like saying you're having 2 halves. 1 whole just means 1. So these are all what we call equivalent. Because what word do you see in equivalent? Equal. They all mean the same thing. Here, how many pieces do I have shaded? 1. How many pieces did I cut it into?
3.
So that's 1/3. So our denomination or our denominator is how many pieces did I cut it into? Now what if I sliced it down the middle here? How many pieces are there now? We got 6 pieces. How many of those pieces are shaded in? I will numerate them. 1, 2, 2/6. Now, did I shade anything else?
No.
Did I add any more pieces to that shape? No, I just cut it up into more pieces. So basically, these guys mean the exact same thing, don't they? Now, what if I were to cut these again? This time, down the angle here. I just got to make sure when I cut it, I got to cut them all into equal pieces. That's all shaded. So, how many pieces did I cut this into now? 1, 2, 3, 4, 5, 6. 6 and 6 is 12. I cut it into 12 pieces. How many pieces are shaded?
4.
1, 2, 3, 4. Again, did I add any more pieces?
No.
Did I shade any more things here?
No.
So we got ourselves 3 different ways to write a fraction, and they all mean the exact same thing. Yeah, if I look at this, how do you turn a 3 into a 6? Multiply by 2. How do you turn a 1 into a 2? Multiply by... How do you turn a 1 into a 2?
Multiply by 2.
Multiply by 2. How about a 6 into a 12? How do you turn a 6 into a 12? How about a 2 into a 4? What if I were to go this way? How do you turn a 3 into a 12? How do you turn a 1 into a 4? All right, so how can you tell if these are the same or not? What is a way to test that? Yes. So that is how you can tell if fractions are equal to each other. If you can multiply or divide by the same number for both the top and bottom. So I'll ask you this. 8 over 9. Is that the same as 16 over 18? Why is it the same? How do you turn a 9 to an 18? 8 to a 16? Oh, good. Well, that seems to be nice. Simplest form, real quick. Is that as simple as I can write it?
No.
Yeah. No, why not?
Because you can divide that more.
I can divide. What can I divide it by?
By 2.
By 2 or by 4? Let's do 4. I'm sorry, let's do 2. 8 divided by 2 is 4. 12 divided by 2 is 6. And you can still divide by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Let's see. 9. 90 over 150. What can I divide by?
30.
I can divide by 3. Divide by 3. That's 30. And 50. And then divide by what? 10. That's 3 over 5. And somebody else just said you could just divide by 30.
You could divide by 10 too.
The reason I'm talking about equivalent fractions is this. We're going to compare numbers like 3/5 and 7/16. Which one's bigger? 3/4 and 52 pennies. Automatically, you already know that this is the bigger thing. Because you know that 3/4 is actually 75 pennies. But it doesn't say 75 pennies here, does it? No, you had to look at that and say, well, I remember that a quarter is 25 pennies. Since I have 3/4, I have 75 pennies. But you don't do that in your head because you already know that because you've been dealing with money all your life. Now you can compare which is bigger, 75 pennies or 52 pennies? 75 pennies is bigger than 52 pennies. It works the same way with fractions. Is it bigger to have 3 of these things or 7 of these things? So what I'm going to do is I'm going to get a common denominator. It's not going to be pennies, but it's just going to be what number can 5 and 16 go into?
3.
Well, you could say 1, but then you have a 5 and 16 again. So basically, to find your least common multiple, just multiply all these. What's 5 times 16? 80. So how do you turn a 5 into an 80?
Multiply by 16.
That means what should I do to the top?
Multiply by 16.
How do you turn a 16 into an 80?
You divide by 5.
So you multiply by 5. Man, I don't know why you're saying different numbers when they're right in front of your face. What should I do to the top?
Multiply by 5.
Good. So now I'm not even going to worry about the bottom number. I know it's going to be 80. All you really need to do is compare the top numbers. So if I look at this, what's 3 times 16? It's 48. 7 times 5 is 35. So yes, 48 80s is bigger than 35 80s. So this fraction is bigger. But in order for you to make sure you can compare it, you got to make sure the bottom numbers are the same. Whenever you compare things, you always have to have the same denomination. So I can't compare $3 with 5 francs in France, can I? I got to find the common denominator for both of those. So if I have 3/8 and 5/16, I don't know which one's bigger yet. So I have to make sure these guys are the same. So my question is, do you know how to make them the same?
Times 2.
I look at this, multiply 8 times 2. What should I do at the top?
Multiply times
Because what's 8 times 2?
16.
Ooh, isn't that what that is?
Yeah.
So do I even need to mess with this?
No.
No, save yourself some time. So what's 3 times 2?
6.
All right, so my question is this. Is 6, which is bigger, 6 or 5?
6.
6. So that means this guy is the bigger fraction. The big side gets the big fraction. All right, in order for you to compare them, you need to have the bottom number be the same. If they are not the same, you cannot compare them. I hope you enjoyed this video. We're going to continue more with fractions in a later video. In the meantime, please watch this one, or watch this one. You can also subscribe when the new video comes out. Have a nice day.
They're both
Yeah, they're both blinking.
They both have the same.
Oh.